Hi, I'm Beth Electrical. Today I'm going to be going through basic fault finding on motors with you. It's just to give you a general idea on how to find certain faults. So rather than just going to a motor that's not working and saying, yeah, that's knackered. Why is it knackered? You need to be able to prove with your readings why it is, rather than getting a customer to replace it in case that's not the case. With fault finding, there's like a logical process in which you would do to find the fault. So some of these tests you wouldn't bother doing because the fault will be apparent from the start, but I'll go through like a few things you can try and then what sort of readings you should be getting, and yeah, we'll go from there, but bear with me. And if you can hear the tapping, that's my dog walking on the floor. I've tried to make a diagram of how a basic system would be laid out, so it's hard doing it backwards. So here you've got fuses or like a MCB or something like that to protect the circuit. Why is this stand moving? And here you've got an overload, so if it's pulling too much amps it will trip it. Here you've got a contactor, so that's where you get the signal for it to come in. I'll go in more detail in a minute. And then you've got some little terminals here where it's going out the panel, so that's all internal to the panel. And from here I just put it to a little isolator and then to the motor. I'm not really too sure how to structure the video, so I'm just going to say things as and when they pop into my head. And my stand's malfunctioning. I'm sitting on the floor and the dog is playing with a squeaky toy, so bear with me. Go through overload first, if it's been overloaded, and that's generally if, like, picture this, you've got a conveyor belt and there's a motor on it and the overload tripped, belt stopped. So why is that? If it runs usually for a few seconds and then trips, it might indicate that it's overloaded. So see your overload. Actually, I've got one down here. This is what I mean. See how it's got, you can set how many amps it is there. So say if that's set at 8 amps or whatever, go on your clamp meter. Bear with me, I don't actually have a proper rig, I'm in my bedroom, so I'm trying my best. So you can put it onto amps, and then basically what you'll do is, say if this is one of the wires coming out of the panel, actually ignore that, I'm going to try and edit that out. So you've got your overload, you've got your contactor, and then you've got cables coming out. I'd usually test it here at the terminals or the bottom of the contactor, get them to run it, and then you'll put L1 in between here and see what it's pulling before it trips. If it pulls 20, 30, 40 amps, then trips, then it's overloaded. That means it's trying to run, but where there's so much resistance, it's bringing the current up and it's struggling because it's overloading, because that's what your overload's set at. If you went to the conveyor belt and had a look at it, you might see that there's a big pile of stones on it, or if it's a pump, the pump might be blocked, or if it's like a motor or something else, there's just some sort of blockage. Another reason it can overload is if you've lost a phase. So to be fair, that's probably one of the first things I'll check. So yeah, clamp each phase, and obviously if you're missing a phase, then one of the fuses might have gone, but then you got to think, why has that fuse gone? I'll get to that. By the way, I take no liability for anything that you do. This is just guidance, so don't blame me if anything goes wrong. So obviously isolate where necessary. With this, if this was a really old panel you've opened and nothing's IP2X, where if you dunk it, like, you get electric shock, it should be so you can't touch anything live with your fingers. If it's too bad like that, I wouldn't even bother going in it, to be honest. It's just not safe. You'll have to do your tests isolated, but obviously you can't really clamp it like that unless you can clamp it at another point. But so one of the first things I usually check, to be fair, is the voltage, to see if you're getting the correct volts there. So where my fuses are up here, let's say they're fuses in this instance, I would check that I've got 230 volt at the top of each one and the bottom of each one. I actually can't see what I'm doing, where it's backwards. And make sure when you test it as well that you go across the phases too. So check you've got 400 volt between it. This example is 3 phase. But what you want to be careful of is if you have lost a phase, because I got caught out on this before. I was testing at the bottom of the contactor when I got the bloke to start it up to see what power I was getting out, and I had my tester down to earth. I was going across L1, L2, L3, and I had 230 volt on each one. I was thinking, well, it's fine, it's getting, so that's my dog whining at me, it's getting 230 volt across each phase. I was like, I don't see what the problem is, but where it went down through the isolator which was on and to the motor, it was going through the windings and coming back to look like I had 230 volt on each phase when I didn't. And a way to double check this is if you test across L1 to L2, L2 to L3 and L1 to L3, and then you should have 400 volt between them phases. My dog falling off the bed. Your voltage tester onto, it's not even a voltage tester, it does loads of stuff. Put it onto voltage, AC, it should already be on AC, but I think if you press a button, it goes off it, and then do the test I just said. And if you are missing a phase, go back to your fuse carrier and isolate the panel, open it up, take the fuses out, and then you want to check continuity. So you stick it on continuity mode. Sure you already know how to test a fuse if you're watching this video, but if not, I will show you. Stick your meter onto continuity, which is the little ohm. And so how a fuse works, well, I think there's different types, but just for this one, we'll say it's the type where it's basically a fuse wire goes in and it's in this little box and there's sand in it, and if the fuse wire overheats, it snaps and then the sand gets in between it, thus blocking the continuity between each prong. So it opens it so the power can't get through anymore because it's blown. So the result that you should be getting is like 0.00 ohms or 0.01, very, very low reading. And if your tester beeps, you should be getting a reading like that because you've just got a little bit of metal there in between it. So, but if you don't get anything, if it says like open or OL like this where it's not touching, that means the fuse is gone. But then you can't just put a new fuse in it and then call it a day, because that fuse went for a reason and that fuse might go instantly again. So that's something you need to be mindful of. You've got a fuse gone, or the overload's tripped, or your MCB's tripped or something. So that could be because there is a short circuit somewhere. And to determine this, well, before you actually do anything, we're going to IR it, which is insulation resistance, and it's basically to check none of the cables are touching. I'm going to go get my other meter for that. So before I start disconnecting motors, I'm just going to test it in the panel first, just to see if there's even a fault. So make sure this isolator here is on, so the power goes all the way through to the motor. And obviously this is all isolated, turn the main panel off, check it's dead, do your steps to check it's dead. This isn't a safe isolation video, so I don't know, maybe I'll make one day. I usually go from these terminals here, and what I will do is, so you want to stick your meter, this is an insulation resistance tester, you can use the Mega one, the Fluke one. I just like this one because I have the multifunction Mega tester and I don't fancy carrying that around on breakdowns because I don't need to do an air fault loop test on a breakdown. I just need to IR most of the time. So you want to stick it to 500 volts. Don't do this test if it's on an inverter because you might blow it up. So say if there is an inverter somewhere here, disconnect your outgoing cables out the bottom of it, because you can't stick 500 volt up it because you'll end up having two problems rather than just one. So I put this black one onto earth and then I put the red onto L1, for instance, brown cable, click test, and then if the cable is fine, you should be getting a reading like that. Or on a Mega, greater than 999 mega ohms, or the Fluke, you get like greater than 299, I think my old Fluke used to do. And that means that the earth is not touching the live anywhere. So if you get to the point where you've tested them all down to earth and they're fine, then there might not even be a problem with the cable or the motor. So then I would also test, this week, get confused. if you was then to test in between L1 and L2 here, you're gonna get a short circuit because it's going through the windings of the motor. So you want to turn this isolator off here, and then you can determine. I'm trying to shit again. So usually if there's a damaged cable, you're going to get a reading between one of the phases and earth. You might not all the time, it might be between two of the phases. But a quick way to check it, starting at the panel, is to have your black probe onto the earth and then your red onto L1. And then you'll test that and you should be getting a reading like this, or greater than 299 mega ohms, or greater than 999 mega ohms, and that means that your live is not touching your earth, which is good. But however, if you was to get a reading 0.01, 0.02, something like that, then either your motor is down to earth or the cable is down to earth. This might be run through a ducting, it might have been chewed up by something, hit with something. So you need to say if it's the motor or the cable. Before you start disconnecting motors, a good place to start is this isolator. If you just turn that off and then retest it from here, you'll be able to tell if the fault is from here coming out of the panel to your isolator, or if it's from the isolator to the motor. And then when it is that, generally it's because it is the motor. If you've tested it and this bit is damaged, it's, say if the reading is 0.001 or something, or between the phases, because also once you've turned this isolator off, you're not going to get any weird readings through the windings. So then you can IR it between the phases to see if it's a short circuit, and then you'll have to replace this bit of cable because that's the problem. Or you then disconnect it from the motor here, and then you can do the same test, IR it, with the cable going to the off isolator to see if it's that leg, and then you can then test the motor to see if it's down to earth. Let's talk about the contactor a minute because I'm confusing myself. So usually you've got some fuses or MCB, some sort of circuit protective device, and that will usually go if there's a short circuit or a, I don't think short circuit's the proper term for it, so don't come at me in the comments, earth fault or something I think it's called. But in the real world, you will call it a short circuit. And then it will go to an overload, or a GV2, or whatever you want to call it. This is when it is the amps, really. And then, I just don't think that's right. Overload, yeah, it makes sense. Then a contactor, and this is basically a switch. I don't know if you can see it in my drawing, but you've literally got your L1 going in, and then your L1 going out, L2, L3, and then when they get to here, it's like an open circuit. It's open, so your power gets there and it gets stuck. It can't go any further. And then this bit will then go out to your motor. The way this switch will operate is if you get a signal on your coil on A1. So this might be a push button, a signal off a PC or anything like that. Let's just say for this instance it's just a go button. And then that will then energise the coil. It will shut the contactor, so it will pull in, and then your power can freely come through. It's basically a switch. So you want to make sure when they are selling the motor to run that the contactor is actually operating. So you want to test on A1 to A2, because A2 is usually the neutral. Test across it on voltage. I don't know how the probe's gone. And then when they get it to run, you want to check that it's operating and you're getting a signal here. And then this will close and then it will go. But another fault you can get is contactors welding in, so they get stuck. See how it bounces? Sometimes they get jammed and they can break, and then you might not get all your phases out, or you might get all of them or one. You can do this test to see if it's working properly live, but safer to do things dead. So we can put this on continuity, and what we're looking for is to check the contactor hasn't welded or anything weird like that. So you want to know that your L1 coming in is going out. So put it on beep. Right, okay, I've done it. Right, hear the beep. The beep means it's touching. If you're confused, do it with your lead. look at the result you get. If you've got, and then you will know if something's touching, if something's made, it will be the result you see. And then do the same test with it open. So if something's open or broken, you will see the result you should be getting. No, hopefully the tester doesn't mug me off again. So, this is actually so long-winded. Check between it, and the contactor is pulled out at the minute, so there shouldn't be any continuity between it. And then go through each of them. Good. That's working. It's fine. And then you confirm it as well. Obviously, with everything isolated, you can also jam the contactor in and then test it, and then it should be. This is just to check the operation of the contactor. You can also do this live by testing the test I said earlier. Check the top of them with your earth to L1, L2, L3, then in between it, and check the bottom too, and you've got 400 between it, because sometimes something does go wrong with the contactor and you're like testing up here, well I've got all 3 phases, but you don't actually have all 3 phases coming out of the bottom of the contactor. And if you are running, a dog distracted me, sorry. If it is running on 2 phases, it might pop some fuses. If it's running on 1 phase, it will definitely pop a fuse. So that is something to look out for, to check if your fuses are going and you're not sure why. Something probably a lot of you know, but if not, I'll tell you again. I won't tell you the science behind it because I'm not a college lecturer or that intelligent to remember that, what I learnt from college. But a fault motor going the wrong way, you already know. You swap 2 of the phases over and it will change the direction. You're usually meant to do it at the end of point, but most people just do it wherever it's easy to get to. So maybe at the bottom of the panel. But I'm sure it's meant to be at the end point, furthest point you can go. Or if it's on an inverter, there is a setting in some of the newer ones where you can change it on there. You go through it, some of the settings, and it's like it says A, B, C, and you can swap it to like A, C, B, and then that will swap the direction, which I think is really cool. I'm sure the Schneider ones do that. Going back to the contact briefly, I'm not going to go into too much detail, but you know I said about watch my drink, dog. Getting a signal onto the A1 for it to run. If you don't get that signal for it to run, there is something wrong in the control circuit. But that is a lot to go through. But something I would say check is emergency stops, because they are usually normally open. So say I've pressed my go button, sometimes that signal will come out the panel to some terminals, go to like an e-stop or something which is closed. I'm actually not pointing anything, I'm just pointing, and then it will go back into the panel and then go on to A1, because it's making sure the safety circuit is shut before it goes to it to tell it to run. So check e-stops and stuff like that, or any safety switches which are linked in the way, will be open, which will stop you getting your signal. I am rambling on. Does that make sense? So let's say you've got to the stage, you've ruled out the supplier's fine, the contactor's fine, the overload's fine, the cable's fine, you get to the motor and you're thinking, well, what is it then? And you're getting your signal, everything's fine. So you think, I'm going to test the windings on the motor. What is that? How do you do it? And what sort of results should you be looking for? I did take some pictures of me doing this, but I'm going to try and add it, but I am not good with technology, so I might not be able to. You want to, obviously everything's off and isolated. I feel like I keep having to emphasise that. So to test the windings, you want to make sure everything's dead, locked off your personal padlocks, so don't turn it on when you're in the middle of testing it, because don't trust anyone on site. Have 1 key for your lock. Anyway, this is rambling on to safe isolation, and that's not what this video is about. You want to take your supply cables off of it. You want to take the link bars off of it, the motor I'm talking about. So then you've just got your 6 studs, and you want to go, put your tester on continuity, and then you want to go on U1 to U2, I think it is. Go across it like that. Watch my drink, dog. And get your continuity reading, and then do the same V1 to V2 and the W1 to W2. All your results should be similar, usually like 0.3 ohms or round about that. Actually, it depends on the motor, but that's the reading I usually get. And just to make sure they're balanced, if one of the readings is like way out, then there's probably a problem wrong with the motor itself, with the windings. But if they're all generally the same, then the motor's usually fine. Going back to what I was talking about earlier, right at the beginning, sorry, it is really hard to put like as much knowledge about fault finding on motors into a video. I just feel like I'm skipping everything and missing stuff. But with the overload, obviously it's pulling too much current. Do you remember what we were talking about with the clamp meter? It's pulling too much current and it's tripping, and I said maybe something's blocked, but also the motor itself might be seized. So to test that, you need to take the fan cover off. Obviously it's all isolated, and then where it's connected to off, and see if you can freely move the fan on it. And if it moves freely, then the motor's generally fine, but if it doesn't, it's seized. So you're telling the motor to run, and it's like, oh, I'm trying, then the amps are going up, and then bam, overload cuts it off. So there is a lot more to motors, safety circuits, control circuits and stuff, but I'm just doing a really simple, really dumbed down version of a little bit of help with fault finding, what to look for. So I hope it's helped someone. If not, I've just wasted like an hour, so go me. Let me know what you think in the video. You can tell me, Beth, you're chatting shit, stop trying to teach people, or you can be like, thanks, that really helped me, or any requests you want, let me know. I think this is going to be really painful to watch. I'm just about to edit it, and I think that's going to be painful to edit as well, and the dog is chewing a bottle lid. All these toys, Cleo. So yeah, I've got to edit it now. Go me. Bye.